Hello, good evening. In this session, we shall understand software cost estimation, how the effort and cost of the software is estimated. It is to be noted that software cost and effort estimation is never an exact science. As the software is not a physical product, it is a virtual product. The calculation of effort and cost and others is very difficult one. There are so many variables that affect cost. For example, the technical, environmental, political, and humans, right? So these are various regions, various factors that decide the cost of the software. All these affect the overall cost of software and effort applied to develop it. Still, if we apply some systematic approach, then we can take a risk and can estimate the effort and cost of a software. The best technique that we might apply in estimation of software cost is the decomposition technique, that is divide and conquer, divide and rule. We can divide a software project into number of functionalities, and depending on those functionalities we can estimate the effort required and thereby cost to develop the software, the duration and all that. So empirical estimation models have been proposed and can be used to complement decomposition techniques, and that can offer a potentially valuable estimation approach with which we can be closer to the exactness. The best approach, the best factor that was considered for the estimation of software effort and cost was taken to be the size of the program. Size of the program we consider in two forms. One is lines of code, LOC, and another one is function point. Size of the program varies depending upon the programmer who is writing the code, the customer, how much static the requirements of the customer is, means how frequently the customers are changing their requirements or they are static, the development environment, the technology that we have opted, language, and all these decides the size of the software program. We can estimate the size of the program that we shall learn in another video. So considering we have estimated the size of the program, we understand how can we estimate the effort and cost of the software. So the models that have been proposed for the estimation of the software cost is called empirical estimation models that use empirically derived formulae to predict effort or cost as a function of size in LOC, that is lines of code, or function point. We may say the cost is directly proportional to the size of the software program. There have been so many formulae, so many models proposed by so many authors. Generalizing all those formulae, all those models, we have derived an overall structure of estimation model as E is equal to A plus B into size in EV, estimated value, raised power C, where A, B and C are coefficients, empirically derived constants. E is effort in person months. EV is the estimation variable, that is in LOC or function point. We have two techniques to measure the size of the software, two approach. One is lines of code, that is called LOC oriented estimation model. Another one is function point oriented estimation model. The best model, the most accepted model is of Barry-Boehm's simple model, which is E is equal to 3.2 into KLOC, kilo lines of code raised power 1.05, where E is the effort applied. And function point oriented estimation model was proposed by Albrecht and Gaffney, where effort is equal to minus 13.39 plus 0.0545 into function point. Now we would see how the effort and cost of the software is estimated, measured. The best model, the most accepted model, was given by Barry-Boehm in 1981, which we call Cocomo model, constructive cost model. So with this model, we can estimate effort and cost of the software program, and after getting this, we can also estimate the development time, that is the duration and the number of people to be deployed on a project. Barry-Boehm proposed three models in hierarchy. First one is model 1, which is also known as basic Cocomo or Cocomo 1 or simple Cocomo, simple model. The second one is intermediate Cocomo or Cocomo 2, and third one is advanced or detailed Cocomo or Cocomo 3. Basic Cocomo model gives us least accurate estimation, that is the rough estimation. Alternatively, more accurate estimation is done with the intermediate Cocomo model, and if we desire the exact, more closer to the exactness, that is the most accurate estimation, then Barry-Boehm proposed advanced or detailed Cocomo. Now we shall understand all these three models, three Cocomo models comparatively. Cocomo 1 is also known as simple Cocomo because the problem environment is very simple, complexity is very low, and we want to get the rough estimate of the software, rough estimate of the software program. In that case, we undertake Cocomo 1, the software project is selected as Cocomo 1, where cost of the software or effort of the software is a function of program size in LOC or function point. This Cocomo is used to estimate the cost of a software project. Also, it is used for the estimation of effort, duration, that is the development time, and number of people to be deployed on a project. If we need more accurate estimation, then we use Cocomo 2. In Cocomo 2, effort or cost is a function of program size as well as 4 cost drivers, that is product attributes, project attributes, personnel attributes, and computer or hardware attributes. Hardware attributes are also considered, as we know the execution of software largely depends on hardware platform of the computer, of the software computer system. These 4 cost drivers include 15 predicators that we would find in a table, and getting that value we estimate effort adjustment factor. With that we estimate the size cost of the software. Now third one is the Cocomo third. Cocomo third includes all the features of Cocomo 2, that is size, 4 cost drivers. Now it includes one thing more, is the assessment of impact of each cost driver on the phases of each phase of SDLC, software development lifecycle. Barry-Boehm classified 5 phases for the development of software. These 5 phases are planning and requirement, system design, detail design, coding and testing, integration and testing. So this Cocomo 3 uses impact of each cost driver on these 5 phases. What is the impact of first cost driver on planning and requirement, system design, detail design, code and testing, and integration and testing? And likewise for the second cost driver and third cost driver and so on. Now, after passing through these 3 phases, software passes through these 3 phases, Cocomo 1, 2 and 3. For the estimation of the software cost and effort, Barry Boehm divided the software projects into 3 categories. One is organic. One type of software project is called organic. Another one semi-detached, and the third one is embedded. So for the estimation, we have to select which our software project falls under which category, whether it is organic or semi-detached or embedded. How can we decide? If our software that we are going to estimate, that we are going to develop, is, if it is large, small means it consists of 2 to 50 kilo lines of code, 2 to 50,000 lines of code, then it is called a small. And if the developer's experience is good on that particular project, means programmers have a lot of experience, problem is simple, team size is small, deadline is flexible, means there is no tight deadline, because these are a small software. If it is delayed, then there is no problem. Requirements are less than rigid, means requirements are changing. Innovation is little required, very little required. In that case, we consider software as an organic type. Means if the size is small, problem is well known, programmers have a lot of experience on that type of project, right? Delivery date is not tight, it is flexible. In that case, we consider the software as organic type. But if the size is a little bit more, that is from 50 to 300 KLOC, that is medium, complexity is medium, not so complex, not so simple, something is known, something is not known. Team size is again medium, requirements are not so too tight or too flexible, that is mixed rigid. Problem environment less familiar. Innovation required is medium, deadline is also medium. In that case, we opt semi-detached, we consider the software as of semi-detached type. If the problem is of salary, mark sheet, then the software project is considered to be of organic type. If the software that we are going to develop is of transaction processing systems like software, utility programs like software, then we consider the software as semi-detached type. And the third one is, if the problem is complex, large enough, that is more than 300 KLOC, delivery date is very tight, innovation is highly required, problem environment is changeable, highly complex, or the problem may be new, the hardware and software requirements are very tight, means the programmers have to work under very tight hardware software requirements, highly constrained, programmers experience is very low, or sometimes might not have any experience on that particular type of project. In that case, the software is considered to be of embedded type. So this was the introduction to software estimation models. In the next video, we would understand the Cocomo 1, then Cocomo 2 and Cocomo 3. So that's all for this time. Thank you.